Okay, last lesson we were working on the triangular inequality theorem, and we might have come up with some questions that looked a little bit different to the ones that we're doing in class. So we're asked here to find, we need to know what the x is, and we're told that the x must be smaller than something and bigger than something. So I just wanted to show you what that is on this particular paper. So the triangular inequality theorem means that if we're looking for A, we know that A must be less than the sum of B and C. So we would also say that B must be less than the sum of A and C. And we could also say that C must be less than the sum of A and B. So that there is the triangular inequality theorem, and we can test it here. Say, for example, if we have 5, okay, 5 is less than the sum of these two numbers, because that's 5 is less than 7 is correct. We can say that 3 is less than the sum of these two numbers, which is 9, which is correct. And we could say that 4 is less than the sum of this and this, which is 8. So all of these facts, all of these are true, so we know that this triangle is completely possible. And now, using the triangle inequality theorem, we can find out what, if we have a triangle here but we don't know one side, we can also find what the maximum length of this is going to be, and we can also find what the minimum length of this is going to be. So we can find the maximum length, and we can find the minimum length, okay, of this unknown one. So the maximum length of it is, the maximum length that D could be is, if we add this together, 6 and 7, we get 13. Now we know that the D must be less than 13, okay? So we can pick any number that's less than 13. So it could be 12.9999999999999, or we can just make it nice and simple. We can say that D needs to be, like, it could be anything around about, say, 12.9. Okay, we'll say just about 12.9, because that's less than. That's the maximum value it can be. Again, okay, so now to find the minimum value, okay, what we do is we subtract this from this. So the minimum it can be is 7 minus 6 is 1. So so if we have that 1 value there, so we know that the D value, it must be more than 1. Okay, because 7 minus 6 is 1. So if it was, if this side was 1, 6 plus 1 equals 7. So what we would get is a degenerate triangle. Okay, if that's 7, one side is 6 and one's 1, it'd be that straight line, a degenerate triangle. So we know that this D value must be more than that 1. So any number that's more than 1, it could be 1.00000000001, okay? But to make it easy, in this particular example, we're going to say that we're going to just use 1.1. So D could be 1.1. So now the size of this particular side D, it can be anywhere from 1.1 to 12.9. And how we write that mathematically is, so the D, it must be more than 1, but less than 13. So it must be more than 1 and less than 13. So the minimum value must be more than 1. The maximum value must be less than 13. Okay, so if we find that again, we've got a maximum and a minimum. We're using this particular one. So the maximum value, to get that, we add these two together. So E must be less than 12, that plus that. So E could be, again, we're going to make it anything like, say, 11.9 is fine. To get the minimum value, E must be greater than, and we subtract these. So we'd get 3.2. So the smallest this particular line can be is, the smallest could be, it needs to be greater than that. To make it simple, we'll just call it 3.3. So the smallest this line could be is about 3.3. The maximum it can be is about 11.9. So to write that mathematically, the E is in the middle. So the E must be less than that 12, which is these two together. And it must be less than, must be, say, greater than 3.2. Okay, we can test that out. So if the value is 3.3, okay, 7.6 is less than 3.3, and 4.4, which is 7.7, which is okay. And the maximum value is about 11.9. So if this was 11.9, so 11.9 needs to be less than this and this together, which is 12. And that is correct. So using the triangular inequality theorem, we're able to find out what the minimum and maximum values of this E value is, or this unknown is.